What slide is that? That's slide 51. All right, let's go back to Alcoa. Here we are at Alcoa again. And we have this reaction. To make aluminum. We're trying to make aluminum. And we balanced this the other day. Help me out here. I think we had we had to put a 2 here to get 6 oxygens. We put a 3 here to get 6 oxygens. So we had to put a 4 here to balance the aluminums and put a 3 there to balance the carbons. And what we're looking at is that 2 moles of aluminum oxide is going to react with, this is setting the stoichiometric factor, the stoichiometric ratios of all of these things. It's fixed by this reaction. These numbers are not going to change. It'll produce 4 moles of aluminum and 3 moles of carbon dioxide. And if you're working at Alcoa, it depends on where you work. I worked at Dow Corning, so I worked in manufacturing, quality, research, on the technical side of things. There was marketing. They were trying to sell stuff. There was the president's office. He was just trying to keep everything profitable and running. And there was the environmental group. They were trying to make sure we didn't pollute the environment too badly and met EPA's regulations. At all these departments within this corporation. So you can imagine if you worked at Alcoa and you're in marketing and you say, oh, we're gonna make the 50 tons of aluminum this month. That's what we're gonna sell. That's what they're interested in. So marketing says we're gonna sell 50 tons of aluminum this month. Manufacturing is interested in this side of the equation. They said if marketing wants 50 tons of this stuff, then how many tons of aluminum oxide do we need to buy to make that? Okay? Marketing doesn't care how much aluminum oxide they buy. That's your problem. You go buy the aluminum oxide and carbon. So you're in the purchasing department. You got to figure out how much of that to buy to make that. You're in the environmental department dealing with EPA's regulations, and they want to know how much CO2 you're emitting into the atmosphere. Okay? They don't care how much aluminum you're making. They care how much CO2 you're producing as a byproduct of what you're making. All right? So everybody has a different interest. This is the primary thing you're making. Okay, now, remember I told you one of the fundamental skills in this chapter is understanding what the molar mass is and how to get it. And I picked this one out because of this equation. 2 aluminums times 26.98 is 53.96. 3 oxygens times 16 is 48. And you could actually put your zeros on here. And you get 101.96 grams per mole. What that means is that 1 mole of aluminum oxide is equivalent to 101.96 grams of aluminum oxide. That's an equivalence. Those things are equal. If I had this much aluminum oxide, I would have a mole of aluminum oxide. What molar mass is telling you. And over here, we've got CO2. What do we do with that factor? All right, one oxygen is 16. That's what you get off the periodic table. This molecule has 2 oxygens in it. So 2 oxygens weighs 32 grams. And so, yeah, okay. All right, this is the number you need right here. You got the right number. You got the right number here. And add that up, okay? So here's the molar mass of CO2, 44.01. All right, so you take the mass of the individual element times the number of those, add the number of those in the formula, and then add it together and you got the molar mass. So I am going to write these numbers right up here. This molar mass is 101.96 grams per mole. This one is 44.01 grams per mole. That's not going to change. Those numbers don't change. A mole of CO2 is 44.01 grams of CO2. Okay, so these relationships here, tell you the things. 2 moles of aluminum oxide is going to produce 4 moles of aluminum. Two moles of aluminum oxide will produce 3 moles of CO2. You can use these factors any way you want to. In other words, here I'm saying for every 2 moles of aluminum oxide I produce, it's going to produce 3 moles of CO2. Or I could say it the other way around. For every 3 moles of CO2 that are produced, 2 moles of aluminum oxide will have reacted. That you can use them both ways. You could use it in this order, aluminum oxide to CO2, or CO2 to aluminum oxide. So let's take that for a minute. And let's do our first problem, our first little problem. If I react 10.7 moles of aluminum oxide, how many moles of CO2 will be produced? So this is a mole-to-mole conversion. I'm given moles of aluminum oxide and I'm asked moles of CO2. All right, now on any of these problems, and these are the kinds of problems you're going to be getting, word problems to solve based on a balanced chemical equation. Start with what you're given. Start with what you're given. Okay, I'll tell you a couple things. Number one, start with what you're given, and don't just write 10.7 moles. You can see we're already talking about moles of aluminum oxide, moles of CO2. So to properly label this number, you have to say what it is, not only the unit, moles, but moles of what? Moles of what? Because you're going to be converting moles of aluminum oxide into, moles of CO2. All right, so now this, we're just going from a mole aluminum oxide to moles of CO2. You want to convert this to this. So this unit has to come down here. So that this will cross out. And this unit has to be up here. That's CO2. That's a 2. And what is that relationship? See, now here's where I come down here and I go, what is that relationship? I'm going to my balanced chemical equation. Let's go back to the balanced chemical equation. It's 3 moles of CO2, 2 moles of aluminum oxide. That's where that 3 and 2 are coming from. So it's 3 moles of CO2. You're going to produce 2 moles of aluminum oxide. And now you pick up your calculator. I've got my numbers. I've done my dimensional analysis. I can see that the only unit left over here is what I'm after. Started with what I'm given. I know what I want. And now I have that unit. This calculator is not turning on. Last week, this calculator wouldn't turn on. So what's happening? So I've got 10.7 times 3 divided by 2. And what do you get? 1.05. All right, and we can round that off to 16.1.
So we are supposed to round it off.
I got 3 significant figures here. These numbers, you say, well, that's only 1 significant figure. No, that is as many significant figures as you need, because the ratio is exactly 3 to 2. Okay, those are exact numbers. So this doesn't, I've been telling you in multiplication to division, you go to the least significant figure. These numbers are exact numbers. So you don't go down to 1 significant figure over here in the answer. This here is going to drive your significant figures. Just think of that number. That is 3.000000. That's as accurate as you need that number to be. Okay? Because it is exactly 3. You get exactly 3 moles of CO2 for 2 moles of Al2O3. All right, it's not about, it's exact. So that's not limiting the significance. What's limiting is how well you knew this number. Yeah, I would round it off to 16.1. Now don't get flustered over significant figures. Yes, we've taught significant figures. I'd like to see the answers in the proper number of significant figures. But if I give you a problem and it's worth 5 points, I mean, it might be a half a point off or 1 point off at the most if you didn't get the significant figures. If you give me 16.05, you know how to do this problem. All right? It's just teasing out exactly how to report it. So don't get caught up in a minor point. I'm not saying it's not important at all. It's just minor to knowing how to do this calculation. Mark.
So will we ever get a question exactly like that where we're going to have to know what the equation is, or will we get the equation and have to balance it with that question?
Okay, on the exam, what I will, because on this next exam, balancing chemical equations is one of the skills you should have. There'll be 3 or 4 chemical equations you have to balance. If I give you a stoichiometric problem and say, tell me how many grams of carbon dioxide would be, or how many moles of carbon dioxide, or whatever, I will give you a balanced chemical equation to start with. All right? Because I want to test both of those skills. And I don't want you getting the wrong balanced equation, and therefore you can't get the right answer. You can't get the right answers to these with the wrong balanced equation. It's a good question. But I will separate those 2 skills out on problems. Okay. All right, let's focus on the aluminum, because if we're working at Alcoa, aluminum is what we're really interested in. So let's do another problem here. Let's say, so this is the second thing. If I react, let's just keep the same number, 10.7 moles of aluminum oxide, how many grams of aluminum will this produce? Okay, so let's just look at it. We know now that for every that we're going to get 4 moles of aluminum for every 2 moles of aluminum oxide that react, right? Getting that right from the equation. So let's start out. Where do we start? On a problem like this, where is the starting point? 10.7. Start with what you are given. You are given 10.7 moles of aluminum oxide. Now you want to go over here to grams of aluminum. That's where you want to go. We don't have a conversion factor for moles of aluminum oxide to grams of aluminum. We do have a conversion factor that converts moles of aluminum to moles, or moles of aluminum oxide to moles of aluminum. This is your stoichiometric factor. Notice here, your answer is going to be grams of aluminum. So the very first thing you have to do is a mole-mole conversion right here. You got to convert these moles of aluminum oxide to moles of aluminum. And you get 4 moles of aluminum for every 2 moles of aluminum oxide. Notice that our answer here isn't going to be 16.1 that we got for CO2, because that was a different stoichiometric factor. Okay, now you don't need to do this calculation yet. Where are we right now? We're moles of aluminum. Now, how do we convert moles of aluminum to grams of aluminum? So we're going to put 1 mole of aluminum right here. And it weighs how much? Is that what you have on there? 26.98? Okay. I didn't know if it was 27. 26.98 grams of aluminum. And notice now that my moles of aluminum have crossed out. And I walked along here in 2 parts now. I've walked along from moles of aluminum oxide to grams of aluminum. Now you can pick up your calculator. And do that calculation. Yeah, boy, we're going to get a lot of aluminum out of that, aren't we? What do you get? 577 grams of aluminum out of that. Yeah, I believe that. 577 grams. Now, you can do it, you can do that calculation two ways. You could do this times this times this, and then divide it all by this. We'll give you that number. Or you could do the entire numerator. You could put this number here and divide it by 2. You know, you could write that number down. You don't have to. You could just run it off on your calculator. This times this times this divided by this. Okay, let's do one more. I'm going to rewrite our equation right here. I'm going to rewrite our molar mass. Well, we don't need that molar mass, but let's do this one. And we now know this one just came right off the periodic table. I didn't ask anybody to go to the board and calculate this. We're just reading this right off the periodic table. It's sitting there, AL. Notice I'm not looking at it. It's 26.98 grams per mole. Yeah, there's a force sitting in front of it, but what I want to know is the molar mass of that stuff. We're going to use the 4 in the stoichiometric equations. So now let's make it a little bit more difficult. I'm going to start out with 897 grams of aluminum oxide. And I want to know how many grams. So if it was in a word problem, if I react, or you react, 897 grams of aluminum oxide, how many grams of aluminum will this produce? Okay, now this is a mass-mass conversion. I'm starting out with the mass of aluminum oxide, and I want to know the mass of aluminum. Now remember, at Alcoa, people aren't walking around in the halls talking about moles of aluminum or moles of aluminum oxide. Purchasing doesn't say, we need to order this many moles of aluminum oxide. The marketing guy would say, you know, get real, quit talking like that. Talk in something I can relate to. What can they relate to? Everybody walking down a hall knows how much they weigh. They understand weight. They don't understand moles. So this is the way we talk. This is the way we work in the laboratory. We weigh out stuff. But once we weigh it out, we do ask ourselves, how many moles do we have there? So where do you start? You start with what you're given. And label it, what you've got there. Grams. Notice we're talking about grams of two different things. So when you write down the grams of something, you need to write down what it is. And I'll try to, I'm going to need a lot of space here to put this all in here. Now I need to convert grams of aluminum oxide into moles of aluminum oxide. So I'm going to need to have moles of aluminum oxide up here and grams of aluminum oxide down here. All right? If that's the unit I want to get rid of, I got to get that unit down here. And one of these is 101.96 grams. 1 mole of aluminum oxide is 101.96 grams. All right, so you can see that we're now at the point we were on the previous problem. We've known moles of aluminum oxide. All we got to do is convert the moles of aluminum oxide to moles of aluminum. That's telling us this has to go down here. And that ratio is you're going to get 4 of these for every 2 of those. Where do I want to get to? I want to get to grams of aluminum. I'm not there yet. I'm close. And now I need to multiply this by 26.98 grams of aluminum per mole of aluminum. And I got the problem set up. Okay, now on your calculators, take that number times that number times that number times that number, and then divide it by 101.96 and divide that whole thing by 2. Divide, divide, divide. Multiply by everything in the numerator, divide by everything in the denominator. Keep dividing. Okay, round that off to 3 significant figures. Four 475 grams of aluminum. Okay? All right, here's another worksheet. It has 6 problems like this. It has 6 different chemical reactions. The very first step is to balance the chemical equation. So let's do number 4. No, let's do number 3. So start working on number 3. Try to balance that equation. And before you start solving the problem, I'll get it balanced. We'll see how we balance it. And then I want you to do this. Number 3. Number 3. I'll write it on slide. Number 3. You can work together on this. See if you grasp what I'm talking about here. Yeah, you have to, I think so. Yeah, you had to balance it.
So we gotta write the molar mass with units and then balance everything. So the molar mass goes up here. What he's saying is find the molar mass for each compound or element.
Okay, balance it. Okay, what do you see that's out of balance right away? NA. We got 2 over here, and we only have 1 over here. Is that balanced yet?
So are we balancing first, or are we finding the grams per mole?
Well, you can't go anywhere without a balanced chemical equation. So let's make sure it's balanced, and then you can dive on into the molar masses and do the problem. So let's just get it balanced for everybody. Is that balanced yet? No, I've got, if I look at my hydrogens, I now have 2 plus 2 equals 4 hydrogens, and over here I only have 2 hydrogens. So if I put a 2 right here, I get 4 hydrogens. And I think now we're balanced. Does that balance it? Okay, now it's balanced. Okay, go for it. I'll be quiet. How we doing?
So when you look up here, 2 of these is one of the, yeah, one of the 3 on the side. That's ratio.
How you doing, EJ?
After like, because these are the molar masses.
Yeah, you got the molar masses, and see, you don't have to worry about these other molar masses right now because the problem only deals with these 2 compounds. So those are the only 2 molar masses you really have to know. Okay, now where do you start the problem? Start with what you're given: 48.7 grams of sodium sulfate. Put grams, because it's not moles, it's grams. Okay, now you need to convert that into moles. How do you convert grams of sodium sulfate into moles? So you're going to want to put the grams of sodium sulfate down here.
So like right here, 2 moles.
And that's exactly why you figured this out. Is that right? Is that right? No, okay, that's not right. Let's look at, see that 4 right there? You need that here. 4 times that.
Okay. I hope it's not.
Yeah, you got 2 times that, 1 times that, and that's 4 times the oxygen. So you don't have the right number there. So you don't have the right molar mass, you can't get the right answer either. Okay, let me just stop just 1 second. What is the molar mass of sodium hydroxide?
40 grams per mole.
40 grams per mole. And what about sodium sulfate? What is the molar mass of sodium sulfate? 142.05. Okay, keep in mind that sodium sulfate has 4 oxygens in it. All right, so don't just go along here. Get your 4 oxygens in there. Okay, go ahead, finish.
Okay.
So we start off with this, and then we find out the molar mass for 1 mole of Na2SO4. So 1 mole of Na2SO4 is equivalent to 2 moles of NaOH, and 1 mole of NaOH, and you find the molar mass of that is 40 grams, and then you just...
Yeah, so just keep in mind, you're crossing that out, you got moles of that.
Yeah, and then
Now you cross that out.
Moles, you cross that out, and then you end up with the G's.
Right, yep, and then that, and there you go.
Yep.
That's good.
And it's 3 sig figs, right? 'Cause
Right.
We start with 3.
Right, start out with 3. You got it? What's your answer?
Oh no, I was looking at the wrong one. So I just separate these 2 and times it by
Yeah.
Okay.
Yeah. So the 4 doesn't apply to the sulfur. It only applies to the oxygen.
Okay. Thank you.
Okay. How you doing?
Okay, so I got this. Would I plug this number?
Yeah, you bring that number down there. And what is that equivalent to? 1 mole of this is that. So put 1 mole of Na2SO4. Okay, so now, see, if you cross these units out, this is where you are. This number, if you did this calculation, it would now be moles of sodium sulfate. But you want to know, this is what you want to know, these grams over here. So you got to convert to these moles. So put your factor in there now. Okay, now moles of sodium sulfate is going to go where? You want to convert moles of sodium sulfate. Yeah, down there. So put moles of sodium sulfate. And up here, put moles of NaOH. And what are these numbers?
This one, was it 2 over 1?
Can we calculate that?
Yeah, where does the 2 go? Yeah, because it's associated with that. All right, so there's 2 moles of sodium hydroxide for every 1 mole. All right? Okay, now that only gets you, you're not done yet.
Yeah, but
That only gets you to moles of
find the
this.
grams per mole.
This is what you want,
Oh, the grams.
grams.
You're just looking at route balance, that's what the number's gonna be.
Okay? You have it, Chloe?
That's why I see why they say write the molar mass. They want you to know the molar mass.
Okay, you got this. 1 mole of this weighs how much? How much? Yeah, that's what 1 mole weighs. So put the 142 in there.
I have no idea.
All right. Okay, let me draw you back together again. Let's start. Where are we? We started at. We've got 48.7 grams of this, and we want to go to grams of this. Okay, now let me just lay out the road map. Here's what the road map looks like. We have grams of sodium sulfate, and we're going to convert that into moles of sodium sulfate. And then we're going to convert that into moles of sodium hydroxide, and we're going to finally convert that into grams of sodium hydroxide, because that is what we want to know. That's the steps we're going through. So we've got 48.7 grams of sodium sulfate, and it's 1 mole of sodium sulfate per 142.05 grams of sodium sulfate. And you see right here, we're this far. This is a 4-step calculation. We're starting with grams of one thing. We want to end up with grams of another thing, but we have to go through this molar conversion. So that gives us moles. We're right there. Now to get from here to here, we have to use the factors that come out of the balanced equation. And we're going to get 2 moles of sodium hydroxide for every 1 mole of sodium sulfate. And we're now here. We're right here. And then if we multiply by 40 grams of sodium hydroxide per 1 mole of sodium hydroxide, we are where we want to be. We're at the unit we want to be, grams of sodium hydroxide. And if we do this calculation, yes?
So based on the balancing equation, you can't say that 1 mole of sodium sulfate is equal to 2 moles of sodium hydroxide. Because of the ratio that's in the given equation.
1 mole of sodium, you can't say it's equal to, but you can say that 1 mole of sodium hydroxide yields, there's a ratio of 1 mole of sodium hydroxide for every 2 moles of 1 mole of sodium sulfate for every 2 moles of sodium hydroxide.
Okay.
But notice, I used it in the opposite way. Why? Because over here I've got moles of sodium sulfate, so I have to put the 1 down here.
Okay. Yeah.
I've got to put the sodium sulfate down here. I've got to use this in the opposite way.
Okay, I went straight to that step and then it messed me up a little bit.
Yeah,
You know, I put that on the bottom.
yeah. You put this on the bottom.
Yeah.
Yeah, so that messed your answer up by a factor of 4, actually. All right, and the answer you get is something like this. All right? Okay. Now, you can see the way this is going. Why don't you take a few minutes and balance these equations, and let's send you out of here with balanced chemical equations, and then you can do the other 5 calculations based on that, and that'll be the first thing we look at on Tuesday. So take a minute to balance those. I'll give you the right answers here in just a second. And then I'm going to tell you about the exam, because we're going to adjust the syllabus a little bit.
Oh, I'm not starting with the action test. I went with watch out. You have this. You can mess with this one. Mess with it.
How you doing?
Not good. No.
Not good?
I'm getting there. Don't worry, I'm getting there. It's working.
Okay. Do you want me to just post these balanced ones? You want me to let you struggle with this and post them? I'll put them in an email or something. I'll just put them out to an email with you with them. So you struggle with that. Yeah, I mean, it's better. No, why do I want you to struggle? I mean, that's when you learn it, right? That's when you learn it. You struggle with those. The first one's an example, and then there's 1, 2, 3, 4, and 5. Okay, let me tell you what's happening with the agenda. I'm really thinking we should have our next exam now, not now, but at the end of Module 7, which is where we are right now. We're at Module 7. The syllabus has us going into Module 8, gases, and then an exam. And I really think that's too much material and too long. So here's where we are. It's today, October 25th, and we're on Module 7. The exam was scheduled for November 6th. Here's what I'm suggesting. Tuesday we'll do some more of this. All right, Tuesday we'll do more of this, and we will finish Module 7. And I would propose that next Thursday is November 1st.
In-class test.
It'll be an exam 2, and it will be over Modules 5, Module 6, and Module 7.
Okay.
So really, Tuesday, you should really shoot for finishing all the homework assignments and quizzes, and finishing the balancing of these equations. We will do some more of these calculations on Tuesday. This is the, if this was Mount Everest, this is the top of Mount Everest, is these mass calculations.
So this is the majority of what we're going to test?
Well, knowing the molar mass, determining molar masses of compounds, using molar masses of compounds in these kinds of calculations, balancing chemical equations, that's the most important part of the exam. All right? All right, and then on November 6th, we will start Module 8. All right, I'll try to adjust that a little bit. So I'll go into Canvas and I'll put out Exam 2 November 1st, next Thursday.
Is it going to be here in class?
Yeah, here in class.
I like that. I don't like going to I like all my friends being around me.
It's really intense. Yeah.
No, that other exam was because I wasn't here.
Yeah.
No, it'll be here in class.
Walk over to the way.
Yeah.